All right. So we're going to start with solving systems of linear equations in two variables. When we did intersections and unions, that's kind of a preview of what we're doing now. An intersection is a system of equations. Now with the inequalities, a system of inequalities, what we're looking at is where there's overlap from two equations. Where two equations are the same. And that's what a system of equations is. We have two lines, okay? We could have linear, we could have quadratic, we could have all kinds of different things, okay? Two equations, and we're looking for where those equations meet. What point do those lines intersect? Okay? And remember, it is an ordered pair. It is an ordered pair. It is an ordered pair. You need to write the point. A lot of you lost points on your last test for x-intercept, for y-intercept, because you didn't write it as an ordered pair. The same is true for our systems of equations. If you just write that x equals this and y equals this, those are lines. Those aren't points. The solution is an ordered pair, x comma y. Whatever the x value is, comma, whatever the y value is. Make sure you're writing it as an ordered pair. And it's an ordered pair that makes both of those equations true. It's an ordered pair that is on both of those lines. It is an ordered pair where those two lines intersect, where they meet. And there's a bunch of different things that we do with systems of equations. So first thing we're going to do is we're going to determine, is a given point a solution to that system? Is a point on both of those lines? How could I find out if a point that is given is located on a line of an equation that is given? Plug it in. We're going to plug in that ordered pair. This is my ordered pair, x comma y. And we're going to see, is that point a solution to the system? So we need to plug that point into both equations and see if it's true for both. So x is -3, y is 1. We're going to substitute it in. -3 minus 1 equals -4. And 2 times -3 plus 10 times 1 equals 4. We need to see if that is true. Is -3 minus 1 equal to -4? Yeah. Yeah. Okay. So that means that the point -3, 1 is located on this line. Somewhere on that line, it goes through -3, 1. We're going to do the same thing on the other side. 2 times -3 is -6 plus 10. Does that equal 4? Yeah. So it means that -3, 1 is also located on that line. So -3, 1 is located on both lines. -3, 1 is a solution. Now in this case it's going to be the only solution, but that's not always going to be the case. Sometimes there will be more than one. Sometimes there won't be any. Plug it in, and it makes both equations true, then it's the solution. Yes, sir.
So if 1 was -1, I'm just looking at the one on the left there, and it was -3.
If y was -1?
Yeah.
Yes. You plug it in exactly as it is. If you have subtraction, then you've got the double negative, so you have to simplify it as appropriate. Okay? Now, another set. I want to see if 4, 2 is a solution to the system. Go ahead and take a minute and try that one on your own. Plug in 4, 2 to both equations and see if it makes it true for both. It needs to be true for both. 2 times 4. 5 times 2 is 8 minus 10, negative 2. 3 times 4. 4 times 2 is 12 plus 8, 4. So the point 42 is located on our first line, but it's not located on my second line. So 42 is not a solution. Now, I want to be very clear. It doesn't mean that there is no solution. That is not what we're saying at all. We are not saying that there is no solution. We're just saying that that particular point isn't one of them. Okay? There could still be a solution. It's just that's not it. Okay? It's just that one isn't it.
So on the test, what would a question look like?
Like that. You would tell me, yes it is, or no it isn't. You'd have to work to back it up.
So it would have first equation, second equation, all that written down.
Well, it would have this. It would say, determine if this is a solution to the system, and then you would have to plug it into both and prove, and then tell me yes or no, based on that work. Okay? Now, solving a system by graphing. If you've got your TI-84, go ahead and get it out. We're going to use it. Okay? You still need to be able to graph by hand. Sometimes it's faster, more prudent to graph by hand, but I want to make sure you're still comfortable using your calculator. And it helps. It is a tool to help you in checking your solutions. Okay? So we have 3 different methods of solving a system and finding out what the solution is. Okay? The first one is graphing. Graphing is how we estimate the solution. Okay? Because when we draw the lines, no matter how good we are, they're not perfect. Okay? They're not perfect. But we can get an idea of where those lines are going to intersect to give us an idea and estimate what the solution is. And then we can verify it algebraically. And I want to emphasize this part. When I ask you to graph, to solve, you will need to verify it algebraically, just like we did here. This is the process of verifying it algebraically. So graphing lets us find the point that we think is our system solution, and then we plug that point back into both equations to make sure it's true. So it's 2 parts. Okay, graphing it and then verifying it. Graphing is going to be an estimate. So we want to solve this system by graphing, and if the system has just one solution, estimate the solution. And then we want to check it. Now, in order to graph using our graphing calculator, we need to make sure our equations are in slope-intercept form. How do I get my first equation into slope-intercept form? Yep. And then what? Divide by -1. So negative y equals negative 2x plus 6, which will become y equals 2x minus 6. So 2x minus 6 is my first equation. Y equals 2x minus 6. Okay? And so, I'm just going to graph that because it's off my thing. Okay? There's a quick sketch. Let's do it in the graphing calculator. All right. 2x minus 6. Okay? Bloop. 2x minus 6. There's my first line. All right? Second one. Okay? So remember, y equals, I'm going to do the pre. We actually walk through it. Let's do that. 2. Oopsies, that's a decimal. 2x minus 6. All right? Note where the variable is, how you put in the variable. Up here at the top. Okay? Notice the difference between subtraction and negative sign. They're different things. You'll use them. Okay? 2x minus 6. And when I graph it, hey, there's my line. Okay? I've got my line. So now we need to find our other line. So we'll get it into slope-intercept form. So 4y equals negative 3x plus 20. Y equals negative 3/4 x plus 5. Okay? So I've got another line. Quick sketch. Into our calculator. See our line. So go down, we got a second line. So I can do negative fraction 3/4. What was it? Plus 5? Oh, I forgot my x. That's important. X plus 5. Okay? Negative 3/4 x plus 5. Alpha and then the variable button. You can. Just make sure you put in parentheses. Otherwise, it's going to put the x in the denominator, and so that's going to give you a rational equation. If it doesn't automatically split into the fraction, you need to put it in parentheses and then x on the outside. Graph it. Hey, there's my other line. So looking at our graph, where does it look like our two lines are intersecting? What point? 4, 2. Okay, looks like 4, 2. Okay, right here, we count over 1, 2, 3, 4 to the right, and it looks like it's up 2. So it looks like our graph is intersecting at 4, 2. Now, that doesn't mean it is intersecting at 4, 2. It could be 4.1 and 1.9. Okay, it could be something really, really close and just off by a little bit. So the graph gives us an estimate, and when we look at the graph, and say, okay, it's about at 4, 2. So that's where it looks. Now we're going to check it. We're going to prove it. We're going to verify it algebraically, which is just like what we did on our first two examples. We're going to take that point and we're going to plug it into both equations. Okay, so it appears to be at 4, 2. We're going to substitute to check in both equations. 2 times 4 minus 2. Is that true? Okay, so we're good on the first front. Oops, that's a 3. Is that statement true? So 4, 2 is our solution. Plug it in to both equations, solve, and we get our solution. There's that slide. The first part is graphing it. You can use your graphing calculator to help you. You can sketch those lines and see where that estimate is located. And then you got to plug it back in and check. Yeah.
Let's say you got like 4, 1.
Then 4, 1 isn't that, and so either you messed up in rewriting your equations. So I would check to make sure that your equations.
No, I
are
know.
good.
No, I know I'm good. I'm just saying because you said on the graph, if you get like 4, 1, 4, 2, that's really matter. But like, yeah.
So if you get the point and you plug it back in and it's not correct, first thing to do is check your equations, make sure they're good. And if it doesn't work, if you know your equations are good and you still didn't get that, that means that the solution wasn't exactly that point. It might be something really close to it, and then we have to use another method to find the actual solution. Okay? And so that's the thing with graphing, is if it's exactly on a point where I have integer values for x and y, then it works fine, because I can plug those in easily. I can easily identify those points. I can plug them in and solve it. But sometimes we'll get fraction answers or we'll get decimal answers. Graphing doesn't help us very much with that because it's hard to see on the graph, is it 4 or is it 4.1? Or is it 5? Is it 5.5? Is it 5 3/4? Okay? So graphing is good for the estimate. If we want a more precise answer, then we have to use another method. Okay? Now before we go to the second method, I want to talk about these graphs here. Alright?
So what is the question going to sound like? There's one thing you have to ask.
They'll say solve by graphing and then verify your solution. You'll see on today's practice. Okay? Solve the system by graphing. If this has one solution. Okay, so both of these lines are shown graphed, okay? And we look at the graph, and they look like they are parallel lines. If the solution to a system is where the lines intersect, where would the solution for parallel lines be? No solution. Because parallel lines will never intersect. So I plug these in and they look like they're parallel. Does it mean they're parallel? Not necessarily. We can verify that algebraically. But the lines appear to be parallel. So let's check it. What do I know about parallel lines besides that they don't intersect? The same slope. So I need to find the slope of those lines. So if we write these equations in slope-intercept form, if I write those equations in slope-intercept form, do they have the same slope? Yeah. What's their slope? 1/3. Since they have a slope of 1/3, they are indeed parallel. Parallel lines never intersect. And if they never intersect, then they can't have a solution. They have to intersect in order to have a solution. We call this an inconsistent system when there is no solution. It's an inconsistent system. Now, this one, we graph both lines and they overlap. Okay? They are the same line. When they're the same line, then we call that a dependent system, and they overlap, so they intersect at all of their points. So we have an infinite number of solutions. They intersect at all of their points. Okay? Infinite number of solutions, every single point on that line is a solution to the system. Okay? Now I want to clarify, it's not all real numbers, because it's not all points ever forever. It's only all the points that are on that line. Now, it has an infinite number of points, but not all points ever. Okay? So, 3 different types of solutions. One solution is consistent, the lines intersect. No solution, inconsistent, the lines are parallel, same slope. Infinite number of solutions is dependent. It's the same line. The graph is the same exact line.
So let's say so basically you have like 2.
Yeah, literally the same equations. If you get them in slope-intercept form, okay?
So basically if you have like y equals 1/3 x plus 4.
Yeah. So see, we have x by itself. If we go ahead and get x by itself on this second equation, I have 2x equals 6y minus 2, x equals 3y minus 1. They're the same line. So if you rewrite them in the same form, they are identical. Now, graphing is estimating. We have 2 methods algebraically for finding the exact solution regardless of what it is. Okay, so even if we have fractions or decimals, we can solve for it. First method we're going to do is called substitution. All right? When we're doing substitution method, you have to get a variable by itself. Okay? Solve the equation for one of the variables. Either get x by itself or y by itself. It does not matter which one. You can do either one. Okay? Sometimes you'll already have a variable by itself. On that last equation, we had x by itself already. On this next one, we've already got what variable by itself in one of the equations? Y. This is y equals. When we do substitution, we take, once one of the variables is isolated, we take the expression on the other side and we're going to substitute it into the other equation. I'm saying that y equals this expression. Okay, y equals 3x plus 1. And a solution is where the equations are the same. where the equations are the same. So where y equals 3x plus 6, I want to find where it is in the other equation as well. So I'm going to substitute this expression in for y on the other equation. I'm just going to drop it in. So I end up with negative 4x plus 2. Now we have to remember to do distributive property. That's the only trick. We have to do distributive because it's 2 times y. And y is 3x minus 6. So it's 2 times all of 3x minus 6. Distribute. And then we solve for x. Negative 4x plus 6x gives me what?
2x.
Okay. So I found my x value. I still need my y value. So what do we think you could do with that x value to get the y value?
Or add, like, keep like. Would you add 12 to both sides? That's how you do it?
Yep. I divided 4 by the coefficient of 2 to get 2.
So y.
No, x was 2. What can I do with x to find y?
Plug it into the equation.
Plug it in. X is 2. Plug it in. Doesn't matter which one. Pick whichever one looks good to you. What's 3 times 2? 6. 6 minus 6.
0.
So y equals 0. So what is the ordered pair where there's 2 lines meet?
2, 0.
2, 0. 2, comma 0 is the solution. Now, if you're given 2 equations where you don't have a variable by itself, you need to rewrite it. Okay? A lot of times people do slope-intercept form. That's fine. Doesn't matter. You just get a variable by itself. And then you can plug it into the other equation. Okay? Now, I got 2, 0. By plugging 0 or 2 into the first equation, I got 0. How can I check to make sure that that's actually true? Plug it into the other equation. Plug in 2, 0 into the second equation and make sure it works out. Mistakes happen. We're all human. If you're not, let's chat. I think Area 51 wants to meet you. Okay. Negative 4 times 2 is negative 8 plus 0 equals negative 8. So we're good. And that's our substitution. So tonight and tomorrow, you're going to practice graphing, verifying solutions, and substitution method. Okay? I'll have a warm-up tomorrow with another example on substitution. It's a worksheet that's on Canvas. I have paper copies of it as well. I want to emphasize, remind you, do not wait until tomorrow to start.